and this is Chow Tell. We have a really special and very exciting episode today. We have a very different studio setup because it's such an exciting and different episode. And in the studio with me today, please welcome Professor Charlie Sykes.
Hello.
Hi, Charlie.
You can call me Charlie right now.
All right. No formalities, but he is a professor, like genuine, right?
Yes, at
At
Tufts University.
Yeah, Tufts. And what are you a professor of?
Professor of chemistry.
Ooh, chemistry and food, not so far apart. And so Charlie is here to show us some really interesting food chemistry. And you work with one particular ingredient, I know, which is a specialty ingredient. It's very hard to get, but we got him, so we got the ingredient. Can you tell us a little bit about that?
So preface, I know nothing about food, unlike you.
You
Raina.
eat it?
I love food, yes, but I know next to nothing about it. But I'm here to help you with a very special ingredient to cool down things, and it's called liquid nitrogen.
Wow. And it's summer, so this is actually perfect timing for this very cold ingredient. How cold is it? Liquid nitrogen.
It's about minus 320 degrees Fahrenheit.
That's a lot of degrees. That's a lot of minus
pretty
degrees.
Cold, yeah.
What does that compare? Is there anything that cold?
No, I think the coldest you'd ever get on a really cold day with wind chill might be minus 100 Fahrenheit. So this is minus 320 Fahrenheit.
Wow.
For you more physically oriented people, it's 80 degrees above absolute zero, the coldest you can ever go. So it's pretty cool stuff.
Wow, that's pretty cool.
Nice pun.
Literally. So what do we, and now this is not child's play here, which is why I have him in the studio. I would not be, you can't buy this stuff commercially, and it's not safe for children to handle, although your son sometimes plays around with it, but under your supervision.
Under proper
Strict
safety
supervision,
yes, of
and
course.
I'm trusting Charlie to strictly supervise my interaction with liquid nitrogen as well.
Yep, we'll try and keep you safe right now.
Okay. Because the little kid in me wants to play with it. But maybe you can show me some stuff that can do. Now, is it safe in terms of, like, we're working with food here, so when people think of like a chemical, especially something like this that requires high safety, and then food, maybe we can talk a little bit about the safety aspect of consuming something made or produced with liquid nitrogen. Yeah,
it's a really good point, Raina. It's totally safe because the air is made of nitrogen. The air we breathe is about 20% oxygen and then 80% nitrogen.
Okay.
So all the liquid nitrogen you'll see on the show today is going to evaporate and it'll just form part of the air. So it's totally safe.
So it's an inert gas in a way?
Yeah.
So in gaseous form, it's perfectly normal. It's right here all around us already.
Yep. Just like fizzy drinks and carbon dioxide, right? You can get dry ice, that's frozen carbon dioxide, which would give you a nasty burn on your hand if you touched it, but of course it's in fizzy drinks and it's totally safe to drink small amounts.
And how does liquid nitrogen get liquid?
They compress air.
Okay.
They compress it down and they take the oxygen out and they use that for hospitals, and then what's left over is liquid nitrogen, so we can fry or cook with that if you want.
So in this room, I don't know how big this room is, but how much liquid nitrogen could we extract out of this room? Like it's highly compressed, I guess, is my point, right?
You need to get me these questions ahead of time. Like,
this is a live
it's
show.
About 100 cubic meters, so maybe a liter. That's a complete guess.
So it's really, I mean, the point being that it compresses tremendously, which means when it warms up, it expands very fast and goes into the air.
And in a minute you'll see steam rising, and that'll be the nitrogen evaporation.
This stuff is so dramatic too. The first time I saw it, I was just blown away. Literally, it was just, it's very witchy looking, kind of spooky and ghoulish.
Yep.
Lots of, eye of nude and.
Yep.
So this is a little bit of a kind of a magical show in that sense. We're going to do some witchery and sorcery here with liquid nitrogen. Let's see first, we'll preface it with doing some smaller experiments to see how cold this stuff actually is.
So as always, Raina, safety first. Let's put our lab coats on. So we actually have a very special lab coat for you that goes with your...
You have to tell me this before you hit it. Charlie's also a big joker. I have to wear this. You know who's going to love this, right? My husband is really into tie and dye.
Yes.
He's going to love this. This is a huge lab coat.
It's actually one of my students, Emily Lewis. It's her lab coat.
Thank you, Emily Lewis, for lending me a lab coat. This is pretty killer.
multicolored dream coat.
Multicolored dream coat. Alright.
So we've got our lab coats on.
You have lab coats on.
I have my glasses on. There's a pair of safety glasses for you.
Super, and you have yours on already. Okay.
Got
Wow,
my
I'm color coordinated. I had no idea. This is great.
Got my special gloves on, so I don't
So what happens if this actually touches your skin? It's
falls off.
it falls off. Do not try any of this at home, by the way.
Yeah.
Kids and parents watching, this is really fun and awesome to watch, but unless you got this guy watching your back, please do not do this at home, even if you manage to get yourself some liquid nitrogen, which would be highly unlikely.
Yeah.
Alright, let's see the stuff.
So this is it. This is my big bucket of it.
Wow.
It's steaming.
It's steaming already. I don't know if they can see this on the camera, but there's another little one.
So this is about half full of liquid nitrogen, and again it's minus 320 degrees Fahrenheit. So if you were to put your hand in there for longer than about 10 seconds,
Yeah,
it would freeze solid and it would literally fall
it would
off.
just fall off.
Yeah.
This stuff, you do not want to mess with.
So let's see.
It doesn't smell of anything.
No.
It's inert. Yeah.
Just like the air. It doesn't.
Yeah.
Shouldn't smell anyway.
Yeah.
The air. So let's see. First experiment. So let's see if we can freeze stuff. So a pair of rubber gloves.
Okay.
You see?
This. Rubber gloves.
Pair of rubber gloves.
Yeah.
And I'm going to carefully dip them in, and then we're going to see what happens to them. So again, piece of rubber glove into the nitrogen.
Ooh, it's frothing.
It's frothing. All the heat from the glove is going into the liquid nitrogen.
So it's basically happening as a heat exchange now. The liquid nitrogen
Yeah.
is using the heat. Wow.
It's frozen. So just check it's cold. And then if I go like this,
No! Oh my god. This was elastic and rubber. Is it
It
too cold to
froze.
touch? I shouldn't touch that.
yeah, we'll warm it up. But you see it's smashed into tiny pieces.
Little pieces.
Then a
Wow,
minute,
it's like a birthday party now.
do another one.
Yeah. That was impressive.
Just want to stop spoiling, it should be frozen.
Wow. That's amazing. And that was seconds. It took seconds to
Yeah.
freeze this latex rubber glove into, like, just crumbles.
Yeah.
That's pretty impressive.
So rubber is normally pretty flexible, but
Yeah.
it's so cold, it's again minus 320 Fahrenheit in
Yeah.
there, so the rubber itself freezes
Yeah.
and becomes like as hard as metal.
It's brittle, so
Yeah.
it's like a thin, brittle metal,
Yeah.
essentially.
But then now it's warmed up, if you feel
So
it.
does the elasticity return?
Yeah, it's back to rubber again.
Oh, yeah. That's a pretty cool quality of rubber, actually, to be able to be frozen and then come back. I mean,
Yeah.
you would not wear this again.
No.
Yeah, so it's lost its complete elasticity, but it's not cold anymore.
Yeah.
But that was crazy. Wow. Wow.
But it's nice you brought me flowers today, Raina.
Yes,
It's very
well,
kind.
it's a beautiful day, and I thought,
Oh,
bring
thank
some
you,
for-
Raina.
You're so welcome.
Shall I destroy them? So let's
Is
see
this
what
why you
happens.
never get flowers?
Lovely.
I'm gonna put a flower in here and see what happens.
Could maybe preserve it so it stays good for a while.
Yeah. Now, if you can see this stuff it's boiling and bubbling, you might be able to hear it, but you can definitely see the mist rising out, which is basically nitrogen steam. No?
Oh, that didn't work so well.
Wow, did it just fall off
All
in
the
there?
leaves fell off, yeah.
All the leaves are inside.
I've got my tweezers.
Tweezers to push them out.
Oh,
Oh wow.
that didn't work so well. Let's try the
But
other
it-
flower.
Let's try the other flower. But this basically froze off. I mean, ow. Yeah, it's still it's toast.
Yeah. See what happens to the, what do you call this one?
I have
Rhododendron
no
or
idea.
something?
Yeah, I think they're not so good with my flowers.
It's not a garden show, is it?
No, it's not a garden, it's a coach.
Ah.
Ooh, now that is a solidly frozen flower. What?
Disappeared.
That's amazing. This stuff is crazy. I cannot quite believe it. Is there? And there's just not. It's a clear liquid.
Yeah, we'll pour some
can't
out.
see much of it.
So sit back, Raina.
Okay. So you have it up there.
So pour some.
You can see some a little bit. And it's just frothing over. It looks like water. It's totally clear. And it's bubbling, and I dare not touch that with my bare hands because the entire metal bowl now is very, very, very cold.
Yeah.
Can I fling one of these in?
Yep.
So here I have a rubber band, just a regular one, and I'm going to chuck it in.
So when the bubbling stops, it should be.
It's bubbling now.
Should be cooked.
So this is basically a form of cooking. It's very cold cooking. It doesn't involve fire, but it involves a freezing liquid. And we have a frozen rubber band.
Oh.
That's now totally, yeah.
Totally brittle.
Totally brittle.
But it should come back to rubber again
And
soon.
we'll come back to rubber again. So
Bendy.
it's similar to that. This stuff is very, very... What do you do with this otherwise when you're not playing around with it and horsing around like we are?
So the main reason we actually have it is we work with a special type of microscope called a scanning tunneling microscope. And with that microscope, it's so powerful you can zoom in to see something as small as atoms or molecules.
Oh.
So to look at those, they move around really fast at room temperature.
Yeah.
So to be able to see them in our microscope and be able to make experiments on them and do things, we have to cool everything down really, really cold and freeze it.
Oh.
So that they stay around long enough for
So
us
they
to do
slow
our
down
experiments.
because of the temperature,
Yep. We essentially
the low temperature.
freeze them down.
So you're freezing at the atomic level.
Yep, yep.
That's and what are you learning from these very cold atoms?
So one of the things we did is we made the world's smallest electric motor, and the reason we had to cool things down so much is that our motor, even at the temperature you see here, at about minus 320 Fahrenheit, is still spinning about 1 million times per second. So we actually use something even colder than what we have in front of us here, which is called liquid helium. And that goes to almost like minus 400 Fahrenheit, or 5 degrees above absolute zero.
Oh wow.
So
that's
that,
really cold.
very cold. So at that speed we could actually watch our molecule and watch it rotate and then turn it into an electric motor because it was going slowly enough for us to see. But at room temperature things are moving around way too fast. Yeah.
And you did so. What did you do with this motor? Like, can it power stuff?
Not yet.
But that's it's an atomic motor then, or a molecular motor.
Yeah, it has about 20 atoms in it, so it's a very small molecule.
Wow, that's pretty cool. You science guys.
We have fun, yes.
We have fun. So I think we should have some fun now because this is a food show.
Yep.
Shall we try some fun with food and liquid nitrogen?
Yep.
So I had this idea, and it's been done before, but I hadn't done it before, and it was really fun. Because it's really hot out, it's summer, and so we thought we use the amazing, awesome cooling power of liquid nitrogen. Watch this. To make one of everybody's favorite things to eat, which is ice cream. I have some ingredients here. We're going to go over and mix them up right here live and then make instant ice cream, or attempt to, here on the show on Chow Tell.
Yeah,
Should
and
we do it?
we've got some fresh liquid nitrogen that doesn't have bits of flour and rubber in it.
Maybe these are edible flowers. I don't know, but we won't risk
So this
it.
will probably taste better than this one with the
The one
flowers
with
in
the
it.
flowers in it. Wow, this stuff is so cool.
So yeah, we're ready to go.
Ready to go. Let's do this. All right, we're gonna move over to our little prep station. Thank you.
Ooh.
Yeah, this is good.
Yeah.
Okay. Check out this scope. All right. So I have here a bowl, and I'm gonna just mix up the ingredients for ice cream. And I'm doing an easy version, so I'm gonna use some. Let's see, a little bit of condensed milk. Let me chuck you a spoon from back there. Actually, one of those spoons would be great. Thank you. Lefty here. Get this out. Alright. We have some of that. It's a very forgiving recipe, so. And we'll put some cream in there because it is ice cream. Yeah, let's switch to that. Alright, you can see this being mixed.
So what flavour is this going to be?
So I thought we'd try a mint and Oreo flavor. So
Ooh.
chocolate sandwich cookies and mint extract. And of course we want to have it look nice as well. So let's see if you got that nicely mixed up. As a base, we'll add some more, lots more cream.
Do the Oreos go first or last?
We'll put the Oreos in last. I have some smashed up Oreos already. We've got them there. And put a little bit of milk in here. Right there. So normally you'd make this mix and then put it into an ice cream machine or a hand churn, and it will be slowly frozen. And we can actually talk a little bit about the chemistry of ice cream too. The reason it's very hard to make ice cream at home in home freezers just by making this mix and sticking it in the freezer is that the ice crystals don't cool quickly enough. And so when they freeze slowly, they become much larger chunks of ice rather than the nice, smooth, creamy texture that we like in ice cream. So the commercial freezing process is a much quicker cooling process that doesn't allow the crystals to become large. So what we really want, and what we're doing here with the nitrogen as well, is a quick freeze process. I'm going to add a wee bit.
So your hypothesis is that making it really cold really fast will make it taste the best?
I think so. I mean, that's basically the process. I'm adding some mint extract here a little bit. We're kind of replicating the process that's used commercially. Well, they don't use liquid nitrogen, but the cooling process is very quick.
Okay.
So bringing it down, and the mixture needs to keep moving. So if it's stagnant, it doesn't work, and if it's too slow, it doesn't work.
So can you whisk fast enough, Raina?
I don't know. We're gonna find out.
I guess that's why ice cream that's been in the freezer too long tastes gross.
Yeah.
It's covered in ice, right?
It changes consistency. It starts becoming icy. All right. So we have this essentially. That's great. Yeah.
So
now
maybe
we're gonna
I'll
add
give
the
you
cookies in.
Oh.
Where did we leave the cookies?
There.
Oh, there they are. Thank you.
Or do they go before the liquid nitrogen?
Oh yeah, they'll go in now, and we can start. We can put some now and some later. We just have some sandwich cookies here. You can pick your favorite kind. These happen to be Oreos, but whatever works. Okay, so we have here our mint chocolate chip. No, mint cookie ice cream. Ice cream base. This is still very liquid, as you can see. Yep, you can see that there.
Smells good.
I know, right? Hopefully it will taste good too. Okay, so let's get this stuff out of the way, and then let's do some chemistry.
So safety first, put your glove on. Are you left-handed, Raina?
I am left-handed.
Right. And you're going to whisk?
I'm gonna whisk. So I'm gonna put this on. Okay.
Right, you ready?
All right, here we go. Liquid nitrogen, bubble, boil and, no, bubble, trouble, boil, trouble. Fire burn and cauldron bubble. Wow! Look at this. It's very hard to see anything that's happening, but I can tell you that it's already thickening up as I'm whisking this. And as the steam clears, you might start being able to see. Oh, wow.
Looks a bit gross, but it smells good.
It smells good. Oh, wow. It's cooled pretty quick. Maybe I haven't whisked fast enough. That's more.
A bit more?
A little bit more. Yeah. Pretty cool. You can see all this stuff bubbling and boiling. This is boiling and yet freezing. It's a very strange experience to have something boiling that's so cold.
Yeah.
It's very new. I'm going to move my hand from here. Let's see.
You don't want another glove?
No, I think I'm good.
Good.
Oh wow, it's definitely cooling down.
So it's freezing faster than Raina can whisk.
I don't know if the whisk
She's
can
a
keep up either.
professional. Maybe a kitchen maid would.
Yeah, I've seen this done with a KitchenAid actually.
Yeah.
I did not bring mine in. Here, we can pour some more.
Yeah.
Freeze this stuff. Oh, here we go. We're at softy consistency now.
Yeah.
Oh, mustache. No big deal. You said 10 seconds before my finger falls off. Okay. See, now I can't even whisk it anymore. It's pretty gloopy there. It's like soft ice cream. And my whisk is definitely feeling this. Oh wow.
So you have to be very careful before we eat this, because if we cool it too much, the
Yeah.
ice cream itself will
It'll
go
be-
to
oh,
minus 300
It'll be so
Fahrenheit,
cold.
and
Yeah.
you get some pretty bad
you don't want
freezer burn on your
freezer
tongue.
burn on the tongue. Yeah.
Yeah.
So that's pretty cold. I wonder if we can try this at softy consistency. Or should we freeze it a bit more? What do you think?
One last one.
One last one. Okay, here we go. Ooh. Okay, let's bring this over.
I've got it.
You got it? Great, thank you. Okay, we're coming over. Look at this. This is definitely not what it was a few short minutes ago.
Smells good though.
It's pretty thick. Look at that.
It's ready for eating.
We will find out. Let's
Right.
see. I don't know if this scoop is going to cut it.
Yeah, look at that.
Oh, look. We have ice cream. It is 80 some degrees outside and it is minus 300 plus
Thank you
degrees
very much.
here in the studio, at least in this bowl. And we have instant ice cream made from liquid nitrogen, perfectly safe to eat.
Well, you say that now, but
I say that now. Well, you told me that. We're going to find out.
I've never done this before. So. Cheers.
Cheers. I hope I don't lose my tongue with this.
It's really good.
Mmm.
Not bad at all.
That is pretty good ice cream. We're opposite the street from Toscanini's, and I think we could give them a run for their money.
Yeah.
It's one of the New York Times calls it the best ice cream shop in the world,
Oh.
but they haven't met us yet.
Yeah.
Mmm. Now, can you see the consistency too is very creamy. Like it doesn't have the crystals of ice.
Oh. It's all that professional whisking right now.
It's a very good whisking skills, yes, and very good liquid nitrogen pouring skills.
Yeah.
Good teamwork, Charlie. If you're ever out of a job, you know we could probably start some kind of a liquid nitrogen food truck together.
Yeah.
That would be cool. Mmm. It's actually very good.
Yeah. I think we could finish this after the show.
Yeah, we might just do that.
Mm.
Mm. Are there other things, food things that one could do with liquid nitrogen? I wonder.
Maybe you could freeze some fruit, right?
Yeah, we could freeze fruit. Is freeze drying? You know that you get a lot of freeze dried vegetables and fruits now. And I wonder if they use a similar process, maybe not with liquid nitrogen, but...
Yeah, I think with freeze drying, you're sucking the water out.
Mm. So I wonder if you freeze it and then dehydrate it.
I don't think you can get the water out. if
You
it's
wouldn't get the
frozen.
water out.
Yeah.
if it's frozen. I have seen some processes though where they sublimate the water basically. They freeze
Okay,
it and
yeah.
then the water sublimates and leaves. My cat would be very excited if we could freeze dry salmon treats instead of buying their fancy salmon treats. I've seen that done. So they cook salmon over blocks of carbon dioxide.
Is that right?
Mm.
Wow.
And it gets freezer burn,
Yep.
essentially.
So I think the problem with freezing fruit is it never tastes as good as when you
Mm.
thaw it out. But maybe if
I mean,
you
fresh is
drop it,
best, but
you drop it in liquid nitrogen, maybe. I
yeah,
don't know.
maybe. I'm very impressed with the consistency of this ice cream.
Mm.
It worked out quite well. So again, there's no way you can try this at home, but you can watch and be envious of us. Here, you see the stuff bubbling and bouncing around.
Or you can make friends with a scientist.
Or you make friends with a scientist. Go to your nearest university, befriend the guy in the research lab who has unlimited access to liquid nitrogen. I hope this doesn't get you into trouble, by the way, with your department.
No.
They don't know he's here.
I should be working.
I've stolen him away on a Thursday afternoon. Oh, is that the flower petals?
Yeah, they're all still in there.
In there. I'm still eating my ice cream.
Do you dare me to put my hand on here?
No.
Really?
I don't know. We haven't signed waivers of, responsibility and liability before the show, so if you lose your hand here, there's not much I can do.
I'll show you a quick trick here.
Alright.
So, minus 300 Fahrenheit, warm hand.
Do you feel anything?
It's gone! Oh, it's fine. Pretty cool.
Pretty cool. Can I just do that?
Yeah, very quick, just in and out.
Oh, it doesn't, if it's dry. Wow. We have liquid nitrogen all over the floor, and it's going to be gone in seconds. In seconds.
So the reason you can do that is because this is so cold, your hand's so hot.
Yeah.
The heat from your hand is making it boil, and it forms a protective cushion around. If you were to keep your hand in for 10 seconds, it would fall off. You can put it in really quickly. It's okay.
It's okay.
It's the same as when you drop really hot water in your frying pan that skates around. It's called Leidenfrost.
Leidenfrost.
Yes. End on a
He's so nerdy. I love it.
Yeah.
Well, you can watch this episode again and other ones, recipes, and see us having fun with chemicals on www.kitchen-intuition.com. Professor Sykes, thank you so much for being in the show. This has been an absolutely delicious episode. Lots of fun. See you next time. Bye-bye. This is delicious.
Oh, really? Because you're like, oh, if it's gross, just eat it.